Lessons 11, 1, and 2, Part B. And we're going to look at transforming the trig function graphs. Last time we looked at how to expand the amplitude and to shrink and expand the period. And today we're going to look at um, how to shift it left and right. And up and down. So we've done this with other functions. So this should not be a new concept. This is what we've done with other functions, but now we're going to do it with the sine and cosine and tangent functions as well. So a phase shift, this is a horizontal translation of a periodic function. Remember, periodic function means it repeats itself. A phase shift of h units moves the graph left if h is less than 0, or to the right if h is greater than 0. This shifts the starting position left or right. A vertical shift, up or down. Vertical translation of a periodic function. A vertical shift of k units moves the entire graph down if k is less than 0, or up if k is greater than 0. This shifts the baseline or the middle line of the graph up or down. So here are the general equations with translation. So last time we looked at a sine of bx and a cosine of bx and things like this. But now we're going to add in a h and k, where h shifts it horizontally, that's the phase shift, and k shifts it vertically up and down. So another way to look at this is with these variables like this, where h is equal to c divided by b and k is equal to d. So these are just two ways of writing the same equations. A and B are the same things that we talked about last class, except now that they're going to be from the baseline, which we'll look at. So reflection, if A is less than 0 or B is less than 0, it's going to reflect across the x-axis. Okay. Remember, inside is the opposite. So inside the parentheses, that h is going to move it to the left, and outside stays the same. So k is up and down. So here are three variations of the sine wave, the sine curve shifted up or down 2 units. So here in the middle, the dark purple is our f of x equals sine of x. Well, if we do f of x equals sine of x plus 2, we move the entire graph up 2. Here, g of x in green is g of x is equal to sine of x minus 2, and we move the whole thing down 2. Now, here we're going to shift horizontally, plus or minus 2. Again, the purple is the basic sine wave. Now, with g of x is equal to sine of x plus 2 in the light purple here, we are going to move the entire thing 2 spaces to the right. So instead of here, now we're going to be starting here for the green one. And for the blue one, we're going to move 2 to the left. So for graphing, we need to find the amplitude, the period, the phase shift, and the vertical shift. We're going to draw a horizontal line at y equals k called the midline, or a new baseline. Find the 5 key points by translation. Remember, divide the period into 4 equal sections, and then sketch the graph through the key points. So let's take a look at an example. Here I've got y is equal to sine of 2x plus 3. My amplitude, A, is just 1. The period is 2 pi. Remember, period for sine is 2 pi divided by b. B is 2. So 2 pi divided by 2 is pi. My h is there anything inside parentheses there? No, there isn't. So h is just 0, so there is no horizontal shift. But k is equal to 3. So we are going to have a vertical shift of +3, so that means my new midline is at y equals 3. And my tick mark is at the period, which is pi divided by 4. So let's draw that. So my tick mark is at pi over 4, pi over 2, 3 pi over 4, and pi. My new baseline here is at y equals 3, and my amplitude is still 1, so the max is going to be 4, the min is going to be at 2, and this line looks like it's off a little bit here, but so it should start right at the y equals 0 here. Or x equals 0. It goes up to 4, comes back to 3, goes down to 2, goes back up to 3. And it does the same thing in the negative direction as well. So I'll give you a second to get those notes down. All right, let's take a look at another example. Here I've got a cosine wave, and I'm going to graph two periods. Okay, the amplitude is out here is 5. My period is 2 pi divided by b, which is 2. So it's going to be pi. My h now is going to be pi. So I'm x minus h, so x minus pi. So I'm going to shift to the right by pi. My k, there is nothing out here, so there is no k, so it's 0. So my midline is still y equals 0. So at the axis there. My tick mark, again, is period divided by 4, so pi over 4. So let's, my phase shift is going to equal the period here, so pi. So what do we have? We have pi over 4, pi over 2, 3 pi over 4, pi. Okay, that's going to be 1 full period. My amplitude is 5. Okay. Now remember, the period shift was pi. So I'm taking the whole thing and moving it over by pi. And it comes out looking like that. So in effect, since the period was pi and the shift was pi, it overlaps itself and comes out to be the same exact graph anyway. So the phase shift here did equal the period, so it's the same graph. All right, let's take a look at tangent. Remember, tangent of the period of a regular tangent function is just pi divided by b. Well, let's see what we have here. Okay, my amplitude is just 1. The period is just pi divided by b. My b here is just 1, so it's just still pi here. My asymptotes, where is cosine going to be equal to 0? It's going to be pi over, remember this equation from last class? Pi over 2 times absolute value of b, which is just 1, plus any number of n pi over b. So it's going to be pi over 2, and then every pi after that. My h is negative pi over 4, so it's going to be a shift of pi over 4 to the left. My k is 1, so my midline is now y equals 1. And the tick marks are at, my period is pi, so pi over 4. So let's draw this. So what do we have? My amplitude is 1. My midline is y equals 1. So my a is going to be at 2 and 0. I have to shift this entire thing over pi over 4. So it's pi over 4 to the left. My asymptotes, okay, were originally at pi over 2, but now I have to shift over to the left by pi over 4. So my asymptotes, no, my asymptotes, sorry. My asymptotes are here at pi over 4, and then plus pi would be 5 pi over 4. And yeah, so then my quarter points here are at 0 and 2, or y equals 0 and 2. So I'll give you chance to graph that. Again, some of these, it'd be nice to practice on your calculator to make sure that what you're graphing is the same thing that you can come up with on your calculator. So again, practice those on your calculator will really help you. Okay, you can come back to this later or take a screenshot of this or whatever you need to, and we'll move on. All right, here is a real life scenario. The number of people in thousands employed in a resort town can be modeled by f of x equals this sine function, where x is the month of the year. So 1 would be January, 2 would be February, and so on. Graph the number of people employed in the town for one complete period. Well, what is the period here? My amplitude is 1.5. The period is 2 pi divided by the absolute value of b. Well, b is pi over 6, so 2 pi divided by pi over 6 is 12. And that makes sense for 12 months out of the year. What are h and k? Well, my h is here at, is going to be a negative 2 because it's x minus h. So we're going to be 2 to the left. And then for my k is a plus 5.2. So my midline is at y equals 5.2. So if we were to graph this and figure out what is the maximum number of people employed, well, it should be January if I'm going to graph this, because since it's a sine function and we're going to shift to the left 2, so period divided by 4 plus h. And if we calculate this on our calculator, it should come out to be about 6,700 people employed. So you might want to graph that and on your calculator to make sure that that's what it looks like for you. All right, so I'm going to give you extra time today to work on the trigonometric function graphing packet, and I will post those solutions. In fact, I'll do that already, so they should already be out there. Um, so, so you should be able to get that done today, so you won't have any homework over the break. So that's all we're going to do for today.